So good afternoon, everyone, and welcome to the 11th technical meeting. This is actually the last webinar we are hosting this year. And today we have an interesting presentation. My name is Fran Vera. I am the events coordinator of the Australian section of the AACE. And yeah, I'm going to go through a couple of housekeeping items before moving into the webinar. So the agenda for today, we're going to look at the procedures about the meeting. I'm going to give a brief introduction about the AACE International and the AACE in the Australian section. Then we're going into the detail and with the webinar, the Microsoft project delay analysis techniques. We're going to have some final questions to the speaker, and we're going to have a networking space at the end. Everyone will be welcome to open their microphone and start talking either to the presenter or to each other. So attendees will be muted during the presentation. If you'd like to ask a question, please make a comment in the meeting chat feature. The speaker may pause during the webinar to answer questions and make comments. So some details about this webinar. We will make this webinar available on the AACE Australian section YouTube channel. And we'll be also posting this webinar as a podcast in our AACE Spotify channel. This will be released very soon. Actually, we're just waiting for some feedback. And I think by the end of this week, we will have the podcast ready to go. And the slides will be shared at the end in a follow-up email. And we'll issue certificates of attendance to AACE members only. Of course, this is valid for CPDs and CEUs as well. And if you want to know more about the future events, you can visit aace.org.au. So the AACE stands for the Association for the Advancement of Cost Engineering. It serves the total cost management community since 1956, and it is committed to the constructive exchange of ideas between members, to the development of technical guidance and quality education throughout a variety of certifications, the recognition of subject matter experts as well. So in the Australian section, we are organized as you are seeing in the screen. It's just the Australian map. We have a representative on each state. We have Luke Virotto in Queensland, Alberto Sanchez in New South Wales. We have Val Matthews in Victoria, and Alan Crowe in Western Australia. We're still looking for someone in Northern Territory and also South Australia. We have some volunteering opportunities, actually. We are looking for 2 more members, membership secretary, training and development coordinator. So if you are willing to spend from 4 to 7 or 8 hours per month, you can drop us a message and we can discuss this further so that you can join us and help us out with all our projects that we have for next year. So in this webinar, I'd like you to welcome Paul Harris. He's the president of the Australian section. He will present to the Microsoft project, delay analysis techniques. Just to give you a little bit of background, many construction contracts specify that a delay must be calculated from the critical path of a program. Often project programs are completed using Microsoft Project, and therefore to demonstrate a delay, the scheduler needs to add delays to the program in order to evaluate these delays. Today, we will understand the various techniques of assigning delays to activities in Microsoft Project. So Paul, I'll hand it over to you and stop sharing.
So thank you very much, Frank.
No worries.
So a little bit about myself. I hold a degree in civil engineering obtained from the UK. I'm a certified cost engineer and a certified Prince 2 practitioner. I've worked in the project controls industry for a number of years, and I've helped a lot of companies set up and run project control systems. I have a Melbourne-based company called Eastwood Harris, and I offer project controls consulting and training services with a strong focus on Microsoft Project, Elecosoft Powerproject, which used to be called Asta Powerproject, and Primavera software. I've written and published over 50 books on these packages in the last 21 years. So my main business is publishing training material and training people on using these software packages. I do get involved in delay analysis a couple of times a year. I often give evidence at arbitration and that sort of thing. And this presentation is aimed at explaining to people the techniques you can use to demonstrate delays using Microsoft Project. So many construction companies specify a delay must be calculated on the critical path of the contract program. Often project programs are completed in Microsoft Project, and therefore to demonstrate a delay, the scheduler needs to add delays to the program to demonstrate and calculate the delay. And therefore I will outline the various techniques for demonstrating delays using Microsoft Project. So first of all, I'm going to talk about what a delay is. I'm going to talk about how to perform delay analysis, so what the process is you should follow. I'm going to talk about delay categories, understanding what delays are, and then assigning delays and software functionality. So the first thing is, what is a delay? And delays can be defined in contracts in many ways, and it's really important that you read the contract and understand it. And if there isn't sufficient information in the contract, then it might be worth negotiating with the client as a contractor before the project starts how you're going to assess delays. So a delay can be an event that impacts on the timing of a project's activities and may impact, for example, on the contract end date, the stage end date, or date for practical completion. So you need to be very clear with the customer what date in the program and in the contract that delays are calculated against, because there could be a big difference between those dates. It can also be defined as an impact to a critical path. So a delay can only be claimed if it's delaying the critical path on a program. It could be an event that consumes float. Therefore, you could be able to claim costs for an activity that has float. It could be an event that causes work to start or finish later than planned. And it's important that you check what you intend to claim as a delay is claimable under the contract. So if you wish to claim a delay under the contract, then you need to make sure that that there is a vehicle under the contract for claiming that delay. You also need to make sure you understand any time bars when submitting claims. And I've known companies who always put their the delays at the end of each month, but haven't read the contract where it says that the contractor must inform the client of a delay within 7 days of a delay becoming noticed or commenced. So again, it's important that you understand the contract terms and conditions in respect to delays. The next thing here is, how do you perform a delay analysis? Well, a delay analysis should be based on evidence derived from project records. So it's really important that you have good project records. I think it's really worthwhile having cameras on sites if you can. If you've got a site like a tank farm where you can put a couple of cameras on and see everything that's going on, that certainly provides solid evidence. If you've got a road or a railway, then maybe you take photographs or videos at the end of each week or something. So first of all, you got to identify the delay and the time period that they impacted on the project, and this must be recorded. You must then select the appropriate delay analysis process based on available data. So depending on when you are claiming the delay, if you're claiming the delay at the end of the project or if you're claiming the delay during the project, depending on what the evidence is that is available, depends on how you're going to claim that, how you can demonstrate the delay. There are a number of delay analysis processes, and you must decide what process you want to use. And it's really useful if you can agree with the customer as a contractor, agree with the customer what process you're going to use. And if you can agree on the process at the beginning of the project, it makes it a lot easier. So you're not going to arbitration arguing about the process, you're only arguing about the delays. So you take the evidence, you then select the appropriate process, and then you impact the schedule with the evidence objectively. You then calculate the impact for each delay. you should be able to assign a responsibility of the delay. Typically, it's to the contractor or to the client. You then calculate the delay impact by each party. So you add up all the client's delays, all the contractors' delays, and you apply the contract terms and conditions to the impacts and evaluate any necessary damages and obviously any EOTs that are granted to the contractor. So delay categories, once you've evaluated delay, it is normally categorized. So an inexcusable delay is a delay by the contractor and an extension of time is not granted. Whereas an excusable delay is an extension of time would be granted. So that's when a delay is ascertained as not the responsibility of the contractor, and therefore an extension of time would be granted. Then there's compensatable, which is an excusable delay granted to the contractor and costs will be paid for that delay. And then there's non-compensatable, which might be an excusable delay and costs would not be paid. And again, these should be clarified under the terms and conditions of the contract. Moving on then, understanding delays. Before a delay may be assigned a category, it must have a value calculated, and delays may occur in different ways. So for example, a delay may occur at the start of a task, so that prevents the task starting. It may occur during the task and therefore split the work, so the task is no longer contiguous. So the crew may start at the work and then can't continue. The crew stops and then starts again at a later date. It may be a reason for low productivity. So again, the activity takes longer than planned. And so again, rather than having a fixed delay, the activity is extended in duration. The delay may affect one task or may affect multiple activities. So for example, a delay affecting one task could be a delay in delivering some equipment, whereas a delay affecting multiple tasks might be a delay where there's adverse weather affecting the whole site. It may be on the critical path or it may be off the critical path. And most contracts state that a delay must impact the critical path. Some delays may initially not be on the critical path and have float, but then resulting in the task being moving onto the critical path. And then in this case, the full delay of the task is not equal to the critical. So the task may be delayed 10 days, but only 5 being on the critical path. So after 5 days, that task moves onto the critical path and a delay may be claimable. Finally, you also need to think about how to demonstrate acceleration. So how, if you've put on extra resources and accelerated, how do you demonstrate acceleration? I'll look at that as well. Moving on, assigning delays and software functionality. This process of adding delays to a program is often not obvious, and there are several techniques I'll document in this paper that shows you the methods you can use to demonstrate delays and calculate delay values. There are issues with all software. It doesn't matter what software package you use. There are issues with all of them. And the issues with Microsoft projects, first of all, unlike Primavera P6, although it allows the splitting of activities into multiple splits that P6 doesn't allow, but products like Powerproject do, it is not possible in Microsoft Project to see the start date and time at the end of the first split and the start of the next split. So you can see the date and time of the start of the activity, the date and time of the finish of the activity. But if you put half a dozen splits in the task and you've divided the task up into chunks, through the interface, you cannot see the date and time of each split. You can only see it graphically in the Gantt chart. Whereas in other products, P6 allows you to split once and you see the date and time of the suspend and resume date. And again, in products like Powerproject, you can see the start and finish of each split. Another issue with Microsoft Project is that the line numbers change all the time as tasks are added and removed, making the documentation of delays more difficult. But this issue may be overcome by using the unique field. But this unique field is the unique ID field is not customizable, so you have to accept the field value that Microsoft Project gives you. Finally, the baseline functions of Microsoft Project are weak, and it gets quite difficult if you've got a large number of delays in a big project to use Microsoft Project, and certainly it's not particularly strong in its baselining functions. So let's have a look at prerequisites for this presentation. There's some pre-reading, and there's something I talk about, which is planning your project. So let's have a look at pre-reading. There are a number of documents that you might want to read before you read my paper, but obviously this is a presentation, so you won't have a chance of reading them. But AACE International has a recommended practice 29R-03 forensic analysis. There's also the 52R-6, which is a prospective time impact analysis as applied to construction. And the Society of Construction Law also has a delay and disruption protocol. You might want to have a read through those to see what advice they have. Finally, before we get on to the techniques, I'll talk about planning a project. Most contracts are silent on how delay claim values should be calculated. And this is the first step in the process, is working out how the delays have got to be evaluated. I certainly recommend that the client and contract agree the method that they're going to use to evaluate delays when the contract is signed, to ensure the process is written into the contract. And some of the issues you need to agree on, first of all, you need to agree what program is going to be used to evaluate the delays. So, for example, you're going to use the original contract program, add delays to that, which is called an impacted as planned. Or you're going to use the latest updated program. So you might decide to update the program every month, and therefore you add delays to the latest updated program, which is a Windows analysis. And again, you need to agree on those. And a lot depends. If you're doing delays at the end of the project and you haven't got updated programs, you may be forced into doing impacted as planned. Next thing is it a delay only to the critical path, or all delays, or delays to activities that have high costs that are considered? I personally think a lot of contracts are very unreasonable where they say the delay has to be on the critical path. Recently, I was involved in a delay analysis for a wind farm project where the contractor had 3 650-ton cranes, and obviously only the one crane was going to be on the critical path at any point in time, and therefore the customer could delay the other 2 cranes without incurring any costs and delivering the towers to be erected in the wrong order with really not getting any penalty. And I thought it was grossly unfair that the contractor should incur standby for these enormously expensive cranes without being able to claim an extension of time because they weren't on the critical path. So when you're negotiating your contract, if you've got activities that are high cost, then you should be able to claim delays to them, even if they're not on the critical path. If you're a contractor, then should you record and calculate both the client and contractor delays, or just the client delays? I've seen contractors just recording the client delays and not their own, and they don't have sufficient evidence to actually substantiate that there weren't concurrent delays and that sort of thing. And I think it's really important that you actually evaluate both the client and the contractor delays. I think contractors should ensure that they have planned the process of collecting delay information such as it's simple to update the program. So you need to make sure that you collect data in a way that you're quite clear when the delay started and finished and that sort of thing. So you need to ensure that site progress reports have unique IDs against all the items in the report. So when you have a daily report, you must reference back to the program, say which activity has been delayed. You need to ensure that claim numbers are used in daily reports and the updated program. So you need to have a cross-reference between the program, the activities in the program, the daily reports, and the claim numbers. Ensure there's a written procedure for the team to follow. So the project team has a procedure. Often you have people on site who are not experienced people. And certainly the first job I had, my company director gave me a set of procedures and said, Paul, you follow these procedures. If you don't follow these procedures, then you get fired. And that's how I learned to do this sort of work initially. So let's talk about methodology now. I'll use a very simple program with a few activities and a finished milestone, a baseline to represent the contract program, so I can demonstrate various methods of assigning delays against a single activity. So this is not going to go into complex delay analysis. Obviously, there are more complex techniques, but generally I find when I'm doing delay analysis, I develop a technique depending on the program and the situation. But this will just have some basic concepts for you. In all the pictures, the baseline is the contract program. It's the lower bar in the pictures. So I'm going to talk about, before we start, unique numbers for tasks, Microsoft baseline issues, And then I'm going to talk about adding delays to represent a delay before an activity starts. I'm going to talk about modeling delays after an activity starts. And I'm talking about modeling delays using a calendar. And then we've got a couple of other topics to talk about after that. So first of all, unique numbers for tasks. It's really important that you have a unique number for tasks so that when you are referring to a program, you are referring to a specific task in a program. And as I say, line numbers change when you filled right, so you cannot use line numbers in delay analysis. So unique task numbers are useful in the documentation of delays, and Microsoft Task ID is a line number which changes when tasks are added or deleted, which in turn makes it hard to use this as a reference in documentation. In Microsoft Project, each task is assigned a unique ID when it's created, and this number is not used again in the schedule, even when a task is deleted. So the unique ID is assigned to all new tasks when the tasks are created by, say, copying and pasting, and they are assigned new unique IDs. So if you take a group of activities, copy and paste them, then the pasted tasks have new unique IDs, and when the old tasks are deleted, the new tasks have the new unique IDs. There are also two other columns that may be used to edit and display relationships. There's a unique ID predecessor and a unique ID successor. And I recommend that you use the unique IDs in claims analysis because they are unique and won't change. So the unique ID will allow users to identify easily which tasks have been added or deleted when a schedule is revised and has been submitted. So again, you can see if a unique ID is missing, then a task has been deleted, and if a unique ID appears, then a task has been added. So here I have a picture showing two sets of tasks demonstrating delays that I've copied and pasted, and it clearly shows that the first set of 5 tasks have a unique ID from 18, 14, 15, 16, 17. So you can see the order that these tasks were created. So you can see I added the summary task after the detailed task, and I've copied and pasted them, and you can see that they've given me 20, 21, 22, 23 when they've been pasted. So you can clearly see that the activities have been copied and pasted, and the new ones have a new unique ID. So then on the next picture here, what I've done is I've deleted the first 6 tasks, and you can see that the line numbers have changed, but the unique ID clearly shows that the ID hasn't changed. So unique ID is really useful for claims analysis and never changes. So let's talk about if you want to reset a unique ID. So you've created a program, and the unique ID is all over the place, and you want to reset them before you submit the contract program to the client. So you want to reset them from top to bottom. Or you want to hide the addition or deletions of tasks, then a new schedule must be created first, and the following process should be followed. So you create a new Microsoft project file with the same start date. You then transfer the calendars from one project to the other with Organizer, and then you need to copy and paste the tasks. If you've got a resource schedule, in actual fact, you need to copy and paste the resources first as well. So you need to copy and paste the resources and then copy and paste the tasks. That way, then what will happen is the unique ID will be numbered from top to bottom. So you'll have a fresh start with a start of number 1. There's, I say, a unique resource ID and also a unique resource assignment ID as well. And again, these will get reset when you copy and paste into a new program. Moving on, what are the Microsoft Project baseline issues? There are a number of issues with the Microsoft Project baseline function, and the ones that affect delay analysis are, first of all, there's a limit to 11 baselines. So if you wish to save a baseline after each update, then you're limited in the number of baselines you may save, which is 11. So for example, I've been involved in projects that have gone for 4 years, and we've updated the project every month. So we've ended up with nearly 50 baselines because we've got one for each month, and we can compare one month with another at any point in time. But in Microsoft Project, you do have a limit of 11 baselines, so you've got to be fairly careful about how you use your baselines. There is a start and finish dates 1 to 10. So if you have an unresourced schedule, you can use the start and finish dates. They're called interim baselines. So you therefore have a total of 21 baselines at the most in Microsoft Project, unless you start using custom fields and that sort of thing that gets fairly complex. So one of the issues with Microsoft Project is the limit of number of baselines. Another thing is that baselines can't have a description assigned to them. So when you create a baseline, it gives you a date it's created, but that's all. So you must decide how you're going to actually document what each baseline starts, what each baseline is for. And therefore, I suggest you might think about using the project information form, and you go to the summary tab and there's a comment section there. And that's probably one of the best places where you can say what baseline is and what baseline 1 or baseline 2 is used for. So again, quite often you have to recycle baselines for different purposes. So for example, in one schedule, baseline 1 might be as at the 10th of July, and then the next one, baseline 1, is as at the 20th of July because you've updated it. So again, you can use the project information form, the summary tab, if you want to. So that's a place where you can record what baseline is. Another issue you've got is Microsoft Project Finish Variance columns do not only works on the baseline field, so baseline start and finish and baseline cost, and do not work on baseline 1 to 10. So that's also a bit of an issue. You may want to create a calculated field showing variance values for other baselines, but then they're not calculated on the calendar. So you do have a problem with the variance column as well, and you need to think carefully about that. And also delay variances in project are shown as positive. So if you are late, it's shown as a positive, whereas more often it's shown as a negative. So usually bad things are shown as negative. So if you look at P6 or Powerproject, they show delays as negative, whereas Microsoft Project shows as positive, which sometimes adds to a little bit of confusion. So moving on, adding delays. I'm talking about adding delays to represent a delay before the activity starts. This is the first one I want to talk about. So you can extend the duration of the delayed act if you want to. So I have a picture here which shows 3 activities, 3 tasks and a milestone. And the simplest method is just to drag an activity, increase the duration. So I've increased equipment delivery by 5 days. It's pushed out the end date, and therefore it shows that the delay of the milestone is 5 days because I've increased the equipment delivery activity by 5 days. And that's a very simple method of doing it. So what are the advantages? Well, it's simple and easy to increase the duration of activity to demonstrate a delay to the end date. What are the disadvantages? It does not show if the delay is at the beginning of the task or in the middle of the task. It does not show the value of the delay because you've increased the duration. I don't have a separate task for the delay value. If the activity is resourced, then the cost to increase might be undesirable if the resource is not working during the delay period. It's not easy to simply zero out the duration of the task to bring the project back to its original status. So if you want to do a collapse schedule, you can't just zero it out. You have to remember how much you've increased that task duration by. It's not simple to identify client or contractor delays, and particularly if you've got a task that's delayed some of the time by the contractor and some of the time by the customer, you'd have to put some text in a note column or in the activity description. So again, it's got a significant number of disadvantages, and my recommendation is you don't use this method, all right? I don't think it's a good method, but it's one that people use. The next one I want to talk about is adding a delay before the start of the delayed task. So what I have here is a picture which shows some tasks, and I've added a delay to equipment delivery before the equipment delivery task, and it shows a delay to a handover by 5 days. So what I've done is I've added a task. It obviously won't have a baseline. It's got a value of 5 days. It's on the critical path, and it's impacted the end date. So the advantage is it's a good method to demonstrate a delay to the start of an activity. It can be used to demonstrate a delay in the middle of activity as long as there's sufficient evidence in the activity description or on the notes or something. The cost of the delay could be modeled by assigning resources to the delay activity. It's simple to change the duration to remove the delay and create a collapse schedule. Multiple delay activities may be used to identify customer or contractor delays, and you can tag them with codes so you can filter on the customer or the contractor delays. So it's possible to code up the activities to be able to filter them out by client or contractor, and then you can zero all the contractor delays or all the customer delays if you're doing an impacted as planned or collapsed as built, whichever way you're going. Well, the disadvantages, I really can't identify any real disadvantages in this method, and it certainly works well for me. So I recommend this is used for all activities when the delay occurs before the work starts. Next thing I'm talking about is extending the duration of a delayed activity. Again, so we're modeling a delay after the activity starts. And if you want to extend the duration of a delay, it's exactly the same as before, and I don't recommend that you use this process at all, whether it's a delay before the activity begins or whether it's a delay after the activity is started. I don't recommend this. Next thing I'm looking at is if you're modeling a delay after the activity starts, do you put a delay activity before the start of the delayed activity? If the delay occurs before the start, then it's best not to put the delay at the start, as one would not want to. You would want to see the actual start of the original task when the task actually started. So if the delay is after the activity starts, so you put a delay before the activity starts, you don't actually see in the schedule when that activity actually started. And you would have to put that actual start against the delay activity. So the next thing you can do, well, sorry, this picture here actually shows, the next picture here shows how I've put a delay activity at the end of the activity here. So now I've got a delay activity at the end of the activity that has been delayed. So again, we're modeling a delay after the activity is started. So the first one is putting one before, whereas now I've put one at the end. And what this does is therefore the actual start of the activity is correct, but the actual finish is not, because we've got a delay activity at the end. So the advantage is that this is quick and simple and allows the assignment of delay to activities to the contractor or the client. It may provide a collapsed program by zeroing out the activities, but the disadvantage is this, like putting the delay at the beginning, but we're putting it at the end, it does not clearly demonstrate when the delay happened. The delay does not impact the end date of the delayed activity, so the end of the delay is now the end of the delay activity rather than the original activity. And the recommendation is that this is suitable when the customer is in agreement to allow delays to an activity during activity execution to be added at the end. So you must have an understanding between yourself and the customer that you're going to model a delay during the activity by putting a delay activity at the end. It's not ideal, but it can be used. Finally, the other way to model a delay after an activity is started, i.e. in the middle of the execution, is to use task splitting. So Microsoft Project allows a split task, and you've got an issue. If the task is fixed units or fixed work, then the duration of the activity remains the worked duration and not the elapsed duration. So if you use fixed units or fixed work, so I've got an activity that's 5 days long in this picture, and I've put a 5-day split. So the duration from the start to the end of the task is actually 10 days. That's the whole duration with 5 days of non-work in the middle. And we're using fixed units or fixed work, then the duration does not change when you split the task, if it is fixed units or fixed work. On the other hand, if you use fixed duration and you put a split in, then when it's fixed duration, then the duration of the task goes from the start of the task to the end of the task, and therefore includes the duration of the split. So again, you need to have a play around, decide whether you want to use fixed work or fixed duration. So when you use task splitting, the advantage it keeps the activity at completion duration equal to the working time if you use fixed units or fixed work. Also, if you want to, you can add a second task underneath. It's simple to demonstrate the delay value by adding the addition of a second activity. So I've got an activity that is underneath the split activity, demonstrating the delay duration of 5 days. But there are some issues with this, but if you want to demonstrate when the delay started and finished, you can add a delay activity underneath with a constraint. So I put a start on constraint, which makes the float value 0. So I've added an activity to represent the split, but it's not logically linked. So the cost of the delay can be modeled by assigning resources to the delay activity if you want to. The final method that you can use is to add new tasks to represent what actually happened and make the original task a summary task. So we've got prepare site. I've made it into a summary task. I've broken it into start prepare site. I've got delay the prepare site, and then I've got finished the prepare site. So what you can do is to make the original task into a summary and add multiple tasks underneath. So breaking the original task into multiple activities, the advantage is it can be used for collapse as built by changing the delay activity durations to 0. It is possible to assign codes and filter out delay activities and then zero out either the client or the contractor to evaluate delays. This method also obviously allows multiple delays. The cost of the delay can be modeled by assigning resources. And the great advantage is it clearly identifies when the work started and finished, when the delay happened. But the disadvantage is the original taskbar changes shape when it's made into a summary task and is not easily identified. But you can format that individually if you want to. And this is very time consuming, but I think is by far the best method to use. So recommendation, if you've got a delay in the middle of a task, I recommend this method if you have time to do it. All the other ones have issues with them, but this is very time consuming. And you need to make sure that you have a budget for this type of work. Next thing I want to talk about is modeling delays using a calendar. So you can model delays using a calendar. You can model a delay against a single activity. So if you want to, you can create a separate calendar for a single activity, put the delay in. So I've got a picture of the calendar form here where I've got the wet ground conditions is added in as a non-work period for 5 days. So you can then put a non-work period in, and then moving over the page here, then you apply that activity to the task that has been impacted, and you can see that the task duration that's been impacted by the non-work period has been increased in duration. You can show that calendar in the background, but unfortunately it shows against all activities, not just the delayed activities. You also will find when you look at the picture is you have a misleading finished variance or delay variance because the calendar has been changed. So you need to be careful that the finished variance doesn't actually clearly identify the delay duration. And you can see from the indicator column that a delay calendar has been assigned to the task. So there's some issues when you modify a calendar to show the impact of a delay. You can see that the delay against the end date is correct, but a delay against the activity is not correct. And these are some of the funny things you have to deal with when you're using scheduling software. So you can see which days are non-working when you change the calendar if you want to. Also, there's as I said, there's an option to change the view calendar, which I've just talked about. So the duration of the task that has been delayed remains the correct work duration. So just remember that when you apply a calendar, then the duration of the task is the work duration. The delay can be removed to create a collapse as built by changing the calendar. The disadvantage of the delay value may not be calculated as an activity, is only available by inspecting the calendar. So to get the delay value, you have to go to the calendar and count the days. Bar necking is not available in project to see when the activity is not working. And this doesn't show the true value of the delay against the activity because of the way this software calculates. You can also use a calendar to model a delay against multiple activities. So again, it's exactly the same method, but you assign the calendar to multiple activities. It's ideal when the whole site is being shut down, say to bad weather, or a large number of activities can be assigned a calendar to represent inclement weather. So I've been involved in projects where we've had windy days where we can't use the crane, wet weather where we can't do mechanical electrical installation, and then wet ground conditions where everybody else is working but we can't do earthwork. So you might want to have multiple delay calendars. Acceleration, there's several methods of demonstrating acceleration. This is the next topic. You can reduce the duration of activity, you can add an acceleration activity, or you can add an acceleration calendar. There's a number of different methods. So first of all, reducing activity duration, I don't recommend. I've got a picture here where I've reduced the duration of prepare site from 5 days to 3 days, and you can see a 2-day decrease in the end date. I don't recommend this method as it's not visible in the program. It's not clear what's happened. You'd have to put a description or a note again. You'd have to edit the task name or add a note. It is a method, but I don't recommend it. The next method is adding an acceleration activity. This is an interesting process where you add a task with a finish to finish and a start to start, and therefore as you increase the value of the duration task, of the acceleration task, the end date comes in. And so an acceleration task is added with a start to start and a finish to finish relationship. So the advantage is that the delay activity may be zero to remove the acceleration. The delay activity may have codes and filtered out and that sort of thing. Also, you can assign costs if they're costs, but the disadvantage is that if you accelerate the last activity, then the last activity will be scheduled beyond the end of the project, which is a problem. And also some people object to using activity in this unusual manner. And this method, as I say, does not reduce the cost, but you could put a negative cost against the acceleration activity if you want to. Finally, you can use an acceleration calendar. So it's exactly the same as the other method where you make the non-work over a weekend work time, for example. And therefore, I've got a picture here which shows I've assigned a acceleration calendar and it's brought in the end date by 2 days. So again, you can do that and you can show you can change the non-work time for all the activities if you want to. So an acceleration calendar is another method, probably a useful method if you've got a large number of activities that you're going to work a weekend against. Finally, removing scope. If you want to remove scope, often you remove scope and that will reduce the duration. You need to make sure you maintain history, and I don't believe you should delete the task. You can reduce the duration to zero, made a comment in the task name or notes. And the other option is to make the task inactive, which is a nice function, but it messes up the float calculation. So I've got a couple of pictures showing both of these. In the example, we're assuming there's no equipment to be delivered or it's being delivered by the customer. We need to show acceleration due to the equipment delivery being removed. So the first picture I've got is where I've just zeroed out the equipment delivery, and you can see the end dates come in 10 days and the float calculations are all good. Whereas the next picture I've got is where I've used the task information general tab and I've ticked inactive. When you make it inactive, the text goes grayed. It has a line through it, but you get a strange float value calculation. And this is a fault in Microsoft Project. It shouldn't calculate like this. I would have thought that if it's inactive, then you shouldn't get negative float, but you do, unfortunately. So updating a program after delays have been assigned. So typically, if you're doing a window analysis you would take the end of last period's program, you would add the delays, you would ascertain the client delays, the contractor delays, and then update the program. So delays are normally added to activities, add each update, and it's normal to actualize the program by applying actual starts and actual finishes to activities being complete, and actual start remaining durations to those that are in progress, and then the program rescheduled to calculate the new end date. Normally at this point in time, the client contractor delays are transferred to a spreadsheet to calculate the sum of the delays assigned to each party at the end of the project. Another option that some companies adopt is not to actualize their schedule, and therefore they keep what's called a live as-built program. This is quite a difficult process. So when you create an as-built program, there are basically two ways to do it. You can actualize it, where the activities have an actual start and actual finish, and you do not get a critical path. Or you can keep it live, and then if the schedule is kept live, then all the delays may be zeroed out to create a collapsed as-built program. I've actually written a paper on this. I've talked about the 3 methods of updating a program. You'll find this at that URL I've got in the slideshow here. Or if you go to any of my websites, you will see that that presentation. I actually presented it at the San Diego conference about 3 years ago, the AACE conference in the US. So yes, there are several methods of updating a program, and I talk about those in that paper. So conclusion, I think Microsoft Project is perfectly adequate for demonstrating a delay in a construction project. The major weakness with Microsoft Project is the baseline functions that make it difficult to evaluate delays because it doesn't save a complete project as a baseline, so it doesn't keep relationships and float and critical path in a baseline. You're limited to 11 baselines. You're not able to name or add notes to baselines. There's a lack of inbuilt variance fields, so there are quite a few issues with Microsoft Project baselining. Also, Microsoft Project is not a strong scheduling tool and has the following issues that make it difficult to manage large, complex schedules. You can't have more than one relationship between two activities, making it difficult to create a closed network, and difficulty in updating a project properly, ensuring all complete workers in the future and incomplete workers in the past, and complete workers in the, sorry, I've got a spelling mistake there. It should be complete work in the past and incomplete work in the future. So yeah, it's difficult to make sure that a project is being updated properly. So that's really the end of my presentation. There are a couple of papers that you might want to read, which is the AACE recommended practices and the Society of Delay and Disruption Protocol. There's a whole load of stuff on the internet. There's lots of websites and things like that you can look at. But that's the end of my presentation. So I was just wondering if there are any questions or comments. Frank, do you want to read those out if there are any?
Yeah, thank you, Paul, for the presentation. It's been really interesting, actually, ideal for someone who works in the scheduling space. We don't have any question in our chat box, actually. I just have a question. What's your, I understand you, Paul, have a lot of experience working not only with Microsoft Project, but also with Primavera. Can we apply this, all the methods you explained today in Primavera, is it?
Yeah, well, certainly there's some, you can use all the techniques in Primavera P6. I've actually written this paper 3 times, once for Microsoft Project, once for P6, and once for Elecosoft Powerproject. These are all on my website at eh.com.au. I initially started writing one paper, but because of the functionality of the software is so different, I felt it was better to have 3 papers. So the Powerproject one I presented on a conference in South America about a month ago by video, and then I'm presenting my P6 one at the Project Controls Expo in February. But yeah, they are very, very similar, but because the functionality of the software is different, if you're using P6 or Elecosoft Powerproject, you do better to grab my papers from my website and read them there.
Okay, thank you, Paul. Daniel Foster is asking if we can have access to your presentation in Project Controls Expo in February. So we certainly were going to share the details of that presentation, because I think it's going to be part also of our calendar as the AACE Australian section. And he's also having another question. Do you recommend any additional software for delay analysis alongside the schedule?
Certainly, when I've done delay analysis, you usually add up the delays on a spreadsheet or something like that. So you need to, if you're doing Windows analysis, then you need to go to something like a spreadsheet to assign the delays to either the contractor or the customer and be able to add them up. So therefore, yeah, you do need to use a spreadsheet. But if you're going to evaluate the delay using the program, then the prime tool is the program. Obviously, if you're not going to use the program to evaluate the delays in it, then there are lots of your scope's open to other methods of evaluating the delays. But I'm specifically looking at evaluating delays doing the program.
Okay, thank you, Paul. Well, Bahi is interested to know if there are common aspects between delay analysis and risk management.
Yeah, well, certainly with risk management, if you're doing Monte Carlo, then you would use the program. But the techniques for risk management, the techniques for delay analysis, I think are different. But again, if there's a risk and you want to add a risk mitigation activity, then you would insert a new activity into the program in a similar way that you would insert a delay activity into a program. So the techniques can be used for delaying these tasks. These techniques I'm showing for delaying activities can be used to delay activities as a result of a risk analysis. So yes, these techniques can be used for risk analysis, or even for when the scope changes. You can use a similar technique. How do you, if you remove scope, how do you indicate that scope's been removed? So yeah, these techniques can be used for other purposes other than just delay analysis. Yes.
Okay. Also, he's asking for recommendations on books to cover delay analysis theories. Of course, you have your own. So
yeah, I don't recommend any specific books. I have read a few articles. I haven't read any books, but there's quite a lot of articles on the website. There's some very good websites around. Obviously, a lot of papers on my website, eh.com.au, but you'll find Planning Planet, 10.6, Planning Academy, those sort of websites regularly come up. If you do a search for delay analysis, they're probably the sort of sites that come up a lot. And they have a lot of good papers that you might want to read. Absolutely.
Okay, great. We have one last question from Stefan. Can you comment on delays caused by HSE issues associated with the overcrowded work site due to the number of contractors on site concurrently working, which is a client decision but impacts on the contractor's efficiency?
Yeah, well, this is really difficult. What you're talking about is not really a delay to the start or in the middle where the work stopped and started. You're talking about it's taking longer. And the interesting thing is, therefore, what you have to be able to do is to ascertain the impact against the activities and say, okay, we've had a drop of productivity of 30, 40, 50%. And once you've recorded what the impact is, then you can impact the activity in the program. I think the issue here is not so much how you impact the program, but how you actually evaluate what the lack of productivity is due to overcrowding and who's responsible for the overcrowding. Because if the contractor is responsible for the overcrowding, then it's on the contractor anyway, and it'd be hard to claim a delay. But if the customer has caused the overcrowding for one reason or another, then the issue is how do you demonstrate clearly that it's not bad planning, but it's an impact outside the control of the contractor that's caused the increase in duration of the task. And these are areas that really are very, very difficult to evaluate. And that's when people end up employing or engaging lawyers and going to court, because you're therefore no longer claiming a delay under the contract and you're going outside the contract.
Yeah, thank you, Paul, for that. Well, we have one more question from Joanna. Can you comment on the earned value management analysis caused by delays? That's actually interesting.
Yeah, so certainly earned value analysis will show whether you are achieving the progress that you planned. And earned value analysis is useful, particularly if the program is not being, or the project is not being executed in accordance with the plan for whatever reason. And earned value will show that you are achieving the amount of work you planned in the time you planned it to be done, although you're not following the program. But my recommendation would be you should reprogram, resubmit the program and rebaseline it. I haven't per se myself seen earned value analysis used in construction programs for delay analysis, but it's not to say that it hasn't been used. I just haven't seen it.
Okay, we don't have any more questions, and I think we are at good timing to close the meeting. Thank you very much to everyone to join the last webinar organized by the AACE Australian section. And thank you, Paul, for accepting being the presenter today. As usual, very, very interesting and insightful. So now, if everyone wants to speak out loud and talk to Paul in a more detailed or private way, you can unmute yourself. I'm going to stop recording And yeah, feel free to start the networking. Thank you very much.
Thank you for hosting it.